Lesson 1.7 is a review of compound inequalities. So a compound inequality is going to be two or more inequalities that have to be both true, or at least one has to be true, and that's what we're going to be looking at here. We'll be dealing with really just two inequalities in the ones we're looking at. So in this first one, we have inequalities containing and. And so if you have the word and joining your two inequalities, that means both inequalities need to be true. We see this sometimes in different situations, but in order to receive some type of children's discount, maybe you have to be older than 5 and less than 12. So it has to fit both of these. So a 15-year-old wouldn't work because although it's greater than 5, it's not less than 12. So both have to be true. You'll see the word and. It means intersection, the intersection of the two graphs of the inequalities. The solution must be a solution to both inequalities. And so what we look for is we look for an overlap in our graph. So I'm going to work through a little process here that I'm going to use to graph these. One other thing that I didn't mention to start with is sometimes you have just one line here with less thans. They both have the same sign, less than, or less than or equal to. You could have greater thans in there, but that's not normal. And we'll talk through what this means as we get to one of the examples. So let's come to this first one. It's nice and simple. We don't have to solve anything. We can say, it says graph the solution set of x is less than 3 and x is greater than or equal to -2. And so what I'm going to do, I'm going to come down here and I'm going to draw a number line. And I'm going to put these two numbers in here. Sometimes you will have to solve and get to these, but we have them already. So we have the number 3 and -2 on here. So we know -2 is to the left of 3. So you don't have to be real specific. Here's the two important ones we're talking about. So there's my main number line, and my answer is going to be on this number line. Now what I'm going to do is I'm going to graph these in this space above the number line. X is less than 3. So since it's less than, I know I use an open circle. And it's less than, so I go to the left. X is greater than equal, so I did this one in blue. Let's go ahead and do this one in red. X is greater than or equal to -2, so still in the space above my number line. It's greater than or equal to, so I fill that in, and I go to the right, because it's things to the right. And now since it's the word and, I want to see where my two graphs overlap. Well, they overlap in this section here. So does it overlap here where this is a closed circle? Well, yeah, sure. A closed circle means it includes that. It's included here. So we're going to go, our answer is going to be from -2. They overlap here, 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 and they come up to here. So they overlap all the way up to 3. Now the question is, do they overlap at 3? Well, this does not include 3, and this does, so it does not. So our answer is right here. This number line is our answer, and that's what I want to see when I see your work. Show these two and show what happens on the number line. All right, now we have one of these one-line things with not an and or written in there, which we haven't talked about or yet, but this means -5 is less than x minus 4, so this expression, and then also, go ahead and put this in a different color, x minus 4 has to be less than 2. And so this can actually split up into two inequalities. -5 is less than x minus 4, and x minus 4 is less than 2. So we can rewrite this as -5 is less than x minus 4, and put this as the green part here, x minus 4 is less than 2, and we solve each of these individually. So we can add 4 to both sides. And we get -1 is less than x. We like to put the variable first, so we can say x is greater than -1. Over here, we would add 4 to both sides. And you get x is less than 6. This is an and. And so now we're back to doing something like this. We're going to draw our main number line. I am going to put these two numbers on here. We have -1. It's definitely to the left of 6, so we'll put them here. X is greater than -1. X is less than 6. Where do these things overlap? Well, they almost overlap at -1, but they don't because this is an open circle. And then they overlap in all of this area all the way up to 6, but again, there's an open circle at 6, so they don't overlap there. So our answer is right here. So there's the graph, and then here was the solving. Now I will say this is not, the part I just boxed in is not the best way to write this. So we can write it still in one line like this. We want to start over here with -1. And so our best answer would be -1 is less than our variable x, which is less than 6. This is the best way to write it. Is this true? Yes, but this is the most efficient way to write it. Next one, we don't want to get to this yet. So now we're going to look at or. These compound inequalities are true if one or more are true. So do both have to be true? No, just at least one. And we use the word or in our everyday language. So if we put an or statement in there, it only means one of them have to be true. So if they're like, well, let the women or children go first. So something like that. The graph of a compound inequality containing or is the union, the word is union here, of the two. The solution just has to be of either inequality. The union can be found by graphing both inequalities. So here we have an inequality using the word or. We're going to have to solve each of these individually to solve it, and then we can graph it. So -3x plus 4 is less than 19. We can go ahead and solve this by subtracting 4 from both sides. Try to keep it in its section here. -3x is less than 19 minus 4 is 15. Divide by -3. We know when we divide by negative, we have to switch the direction of the sign. So dividing by -3 gives us -5. There's one part. Over here, we're going to add 3 to both sides. That gives us 7x equals 21. Not equals. Wow, nice 7. 7x is greater than 21. Divide both sides by 7. And we get x is greater than 3. So we have an or. Here, it looks like our solution here. Let's go ahead and graph it. Graphing can oftentimes show a few things. We have -5, and we have 3. Up here we have x is greater than -5. Well, there's -5. We want it to be greater than -5. X is greater than 3. Now remember, this is not and anymore. This is or. So we want at least something has to be true. Not both, but one. So as we look on our main number line that our answer is going to be on, is this part of our number line covered over here to the left of -5? Well, this is not covered. So anything that's covered by any part works. Not covered, not covered. -5 is not covered, but just to the right of it is. So we have an open circle here. This is covered, 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 covered. Is this covered at 3? Well, we have an open circle here, but this covers it. So 3 is covered, and everything to the right of 3. So I'm going to bold this. So our answer here turns out to be that x just has to be greater than -5. We didn't need this part. This is kind of like someone saying you have to be, like, to win a certain prize or something, you have to be greater than 18 or you have to be greater than 21. Well, anyone greater than 18 or older than 18 fits that, so you don't even have to put the 21 in there. So our answer, here's the graph, and here is the best solution. So don't write it like this, because that's too much information. You can just write x is greater than -5. This last one is a word problem, which is a good word problem. Makes you think through this a little bit. So Carrie has received scores of 79, 87, and 95 on her first 3 tests. What score could she receive on her next test to maintain a B test average? B is from 80 inclusively, so it includes an 80, up to 90, which exclusively a 90 would then be an A, so you don't want to include 90. Well, thinking about averages here. So she's taken 3 tests, she's going to take another one. So what we can think here is, as she takes these tests, her average, so she has a 79 plus an 87 plus a 95, and then she's going to have a 4th test, so plus x, and we'll let x equal her 4th test. So this 4th test is x, so add these 4 up and divide by 4. And this is her average. Well, we can make this look a little bit simpler. We could add these 3 together. 79 plus 87 plus 95, that's 261. And so that's her average. Now, what do we want to know about her average? We want to know, or what, not really about her average, but her 4th test. We want to know, what does she have to get here to keep a B? Well, a B, you have to be greater than or equal to 80 and less than 90. Did you hear that I said and less than 90? So it's a compound inequality, which has to do with and, or intersection. So what we're going to do here is we're going to say, well, her average, 261 plus x over 4, needs to be greater than or equal to 80, and her average has to be, I'm sure she would be okay with getting something higher than a B, but in order to keep a B, it would have to be less than 90. The average would have to be less than 90. So we're trying to solve for this x here, which will tell us her 4th test score that she could get. So it's going to be some type of range. Maybe she can get a 90, maybe she can get a 67. So we're trying to find that range. So let's solve both of these. We're going to multiply, in order to get rid of this 4, we're going to multiply both sides by 4, and we can do that over here too. So we'll work through both of these inequalities at the same time. Multiplying by 4, this will reduce. We'll get 261 plus x is equal to 320. And over on the other side, we get 261 plus x is greater than, I'm sorry, I put equal to here. This is greater than or equal to 80. I made a couple mistakes as I went through here. Good, we caught those. Greater than or equal to 80, because you want to be higher than 80 to get a B, and this actually should be less than 90, not greater than 90. And 90 times 4 is 360. Subtracting 261 from both sides gives us 59. So subtract 261 from both sides here. You get 99. And so I keep doing it. So this should be greater than or equal to again. So her test score, x, has to be somewhere between 59. So remember how we did this before. 59 is less than or equal to x, which is less than 99. So as long as she gets some score between 59, can include 59, all the way up to 99, she'll still keep a B. This means, so this is our answer. Let's just think about this just for a second more. If she gets 100, that would actually bump her up to an A. If she gets to 58 or lower, that would bump her down to a C and maybe even lower depending on what she gets.